Alright, so for this section of the video series, what we're going to show you is the function of the Hydrautomat, as well as how it applies to the actual Hydrautomat. So this is probably the best way to explain everything, is just by showing you the actual original patent, which even the actual patent itself doesn't really look like that in real life as it did in 1927, I guess, but this here shows the fundamental concepts of everything. So what we're going to do is we're going to explain what each and every tank is, and where the hoses go and things like that. As you can see, they're a little cramped together, unfortunately, so it's kind of hard to exactly point things out. I don't know, maybe I can use this to point things out and try and show you the best I can that what each and every hose does. But anyway, we're going to show you the tanks, we're going to show you the hoses, and we're going to show you the function of this whole Hydrautomat, what everything does. So it's probably going to start out right here, showing you what the feed tank is, showing you where the tanks are first. First I'll show you where the feed tank is. That's this one right here, marked G. And that's where the wire comes in right here. This right here, this little line you see right here, that's a high water mark, and right down here is a low water mark right here. So this right here would be just like, you know, a river or something like that, and this right here where it would fall would be like downhill some distance or whatever. I mean, you could have like a dam or something like that, so you could have a dam wall, like have like a dam or something like that here, and a wire would feed into this, and this here would be on the other side of the dam where it's lower, or something like that. Either way, you need a differential of water level from the high mark here to the low mark. That's where your differential is, and that allows it to raise up higher. And with something like this, you can depends on the dimensions. The original Hydrautomat was like 8 feet high, and it could lift water like 15-20 feet. So it all depends on the dimensions of it, as well as the volume of the operating tank, and so on and so forth. But first I'm just going to explain to you what the tanks are. So this here's the feed tank. This here's the operating tank. I guess I forget which is the head race and the tail race, but I do not like using those terms, head race and tail race. I would always use stage. So this is the first stage of it, second stage, third stage, then reservoir. Right here, this is actually called reservoir. I don't know what the head race and tail race is. I don't even know what a race is. So this is such an archaic term that from now on I'm just going to be using the term stage. You know, like a multi-stage rocket, you know, you got the first stage, you know, and as you get higher into orbit, you get the second one, and so forth. Same thing here. And showing the other components here, we have the air tube, which is right here. We have the siphon. We have this little switching device right here, which is also hooked up to a valve by an eccentric gear. And we have the also have a breather tube here too. So first, going to explain what the tubes are. This right here is what I call the feed tube. I don't exactly know what it's called. It might be called a feed tube right here, and that leads from the feed tank into the operating tank here. Then you have a siphon, which is this right here. And as you can see, the siphon consists of both the siphon, which is this tube right here, as well as a trap right here, so that when the water in this fills all the way, not fills up, but drains all the way out, what happens is that this won't suck back in through here. So if you just had a pure siphon that would come like from here out to here, when this thing ran out of water or whatever, it would probably just want to suck back up through here. Instead, that's negated right here by this trap. So that's what the traps are for. That's what these U's are. When you ever see U like this, that's a trap. And when you see something like this, this is typically a siphon or something. So that's what those hoses are for. This is the air tube right here. And this is used to pressurize as well as create a vacuum, so you can use positive pressure, which it pushes down on things, and you can use negative pressure, which sucks on things. Right here, and that's the tube to convey that to these tanks, and it starts from the top right here, so it deals with the air pushing on the water, or the air sucking up, and then it sucks the water up along with it. And I have these tubes right here, which are the input and output tubes. The input tubes always go out through the bottom. You always find an input tube on the bottom of the tank. It's just usually a fitting or something to connect the bottom of the tank to the tube. Goes out like this, up through here, and then goes to a tall pipe at the top. And as you can see here, it's kind of like a dome or something like that. That's cute. You see this little dome here where it's like that? That's probably just to make extra room for this pipe here going up at the top like this, and kind of maybe to avoid the air tube or some kind of function like that. Maybe it's listed in the patent there or not. I don't know. I haven't read the whole thing completely, but I know how the whole thing works. So there's just this is trivial anyway. I mean, you don't really need something like that. So anyway, you have the input tube going up through here, goes out through the hose here. And the reason why you have it so high is that if this was connected directly at the bottom and the wire would just spew out, as opposed to going a little bit further from the top here, what would happen is all the weight here in this tank, or most of the weight, kind of in like a V shape, all that weight would just be pushing down on this tube here, and you have a lot of back pressure pushing back down on it, and make it harder for this to push upward. So what you do is you just have a tube going up through here, so that what happens is the water just, it might resist the tube, but the tube, resists that water pressure there, and it doesn't impede the incoming flow. So what happens is the water can flow up here freely, only having to resist the weight of itself, of the water through the tube, rather than the water of the tank, and then it just goes out through the top and falls down, like that. So that's how your input tube here works. And you have the output tube, which is same thing as it was here with the feed tank. It's located at the bottom, goes up through here into a tall pipe again. Same thing here again, and then same thing here again, and it just falls into this reservoir to the top. The reservoir is open to the air, and same as this right here. This second stage here is open to the air, and yeah. And the only difference I would have to these two tanks right here are closed off. These are not exposed to the atmosphere. These right here are completely closed off in a vacuum, I guess you could say. They're totally sealed off, so that when there's suction, it doesn't pull air from in here and breaks the vacuum. And it can also pressurize so that you don't have leakage going out through here. So that's what this is all about. And this right here is a breather tube. As you can see, it runs here from the bottom of the tank, nearly the bottom of the tank. The tube runs up directly out through the top, and through the bottom, and then out through basically just above the tank here. And this will pour out through here. Now the purpose of this is that during the pressurization cycle, when this thing is filled with water, when there's pressure here, it pushes it up through this tube right here, and it just pours directly out, as opposed to having to go through the trap. Instead, it can just go make a beeline right through the top of the tube, the tubing here, or pipe, or whatever you're using. And this right here is a close-up of the top of this thing right here, which is actually a check valve. This is kind of like a either homebrew version or whatever they used to use back then for check valves, but that's exactly what this is. So the wire can be pushed out, but what happens is when there's a vacuum, this door here, instead of being pushed out, it gets got tongue-tied there. It gets sucked back in like this, claps shut, and closes, and doesn't allow any air or water to go back through into the system and break the vacuum. So it can only go out, but not back in. So that way you can just push it out, and then when it's on a suction cycle, it closes, and nothing breaks the vacuum here. So anyway, I'm going to go now through the function of this thing and show you exactly how this works. You have the feed tank here, which has usually what happens is that this switch here, as you can see, there's a counterweight here, and there's a paddle, and then there's this little fulcrum here, so it's on a lever system, and this whole lever here is hooked up to an eccentric gear, and it's hooked up to a valve. Now normally, this right here is when it's in operation, when the siphon's activated. When the siphon isn't activated, what happens is this counterweight takes over, and the counterweight's down here, and this little switch or paddle or whatever is up here where this siphon is. So what will happen is this will be open. So when this is down, this here is open, and when this is up, like you see here in this drawing, this right here would be closed, because you can see this is all full and stuff, and this is empty, of course, with air. So what happens here is that this fills with water. The switch is open here. This would be down, and this would be up. This would fill up with water, and eventually start filling and filling. This would get filled with water, and this would fill up along with it. And what eventually happened is it would start compressing the air in here. This would fill up here, and the water would start to fill up and then eventually go out through the siphon, because this right here would become compressed. And also, even if this wasn't compressed, you know, the water would still fill up to here, go up to the top of the siphon, and then go back down like this. And then would press this little switch here that would be, you know, the switch is down here right now in this illustration, but when it's filling up, it would be up here. Sorry about that. And it would just go down, push the switch down to place the weight of this counterweight here, push the counterweight up, and also push this lever up here by the eccentric gear you see here, and push this up, and then we close the switch. Now what happens is normally when this thing's draining out, what would happen is the water from this feed tank will go up through here and then go out through here. But since this is all closed off, no water can replenish in this. So this is in a sort of a partial vacuum, and it's constantly draining out through the siphon. So by hydraulic pressure, by hydraulic action, what happens is this slowly goes out like this, and it kind of acts like a piston made out of water. It's like a fluidic piston is what it really is. It's very interesting how it works. And it goes down like this, and you have this finite amount of air right here that's being sucked, that's being pulled on. Because what happens is this is going down here, and you have to have something to replace that. You have something to take the place of this water as it goes out through the siphon here. So what happens is the air gets sucked up along with it and creates a negative pressure, creates a vacuum. Now when that happens, this right here, this tube is still open. So this becomes a negative pressure right here, and this becomes a negative pressure. So this area right here, the pressure becomes less than this here, and eventually it's kind of like reversing gravity or something, and it just sucks it up through here because the water is heavier here than it is, then the pressure is higher here than it is here, and the water gets sucked up into the top here. And what happens is it won't directly suck up through here unless it's like right next to it or something, or it's a really high vacuum, which doesn't happen with this device as it is now. And what it does is it just falls out, gets to the end of the tube, falls out, and then deposits here at the bottom of the tank, and also fills up this trap as well. And it just slowly fills up as this thing drains out. Now what will happen is this operating tank only has so much water in it, right? So what it'll do is it'll go from the top to the bottom, and eventually there'll be so little water in this thing that the siphon will stop moving. The siphon will stop working here. The water will turn off basically. It'll go back up through here, and a little bit will go back into the operating tank, but the rest of it will sit here in this trap as well as the bottom part of the tank. And since there's nothing coming out through this siphon here, what will happen is this switch or paddle tray, whatever in the world this thing is, will go up, because what happens is this counterweight is still bearing down, and there's nothing here to counterbalance the counterweight or whatever. So the counterweight will drop down, this will go back up, and as this drops down, it pulls this lever here back down. This is eccentric gear, I guess that's what it's called, and it pulls this down and opens it back up again. So what happens is this water goes here, kind of replenishes that partial vacuum, and it pushes up on the air again. And what happens is as this thing fills up, the piston pretty much made out of water, I guess you could say a water piston or something, is essentially what this thing is, goes back up again, and then pushes the air back down. Pushes the air back into these tanks. Now the tanks are full with water, right? So what will happen is that the water will be pushed down, instead of going down into this feed tube here, which as you can see you have partly you have this right here to resist against that. So what happens is the water will be pushed down into here, because the water level is above these tubes usually, and I'll go up through here. And also on my device I have check valves here too to make sure there's no backflow going back from this tank into this tank and from this tank into this tank. So anyway, on the pressure cycle of this thing, this air pushes down on the water, pushes it back down, and instead of going through the feed tube where it first came out from, it goes out through this trap and up into here. So the pressure becomes higher than here, and it pushes it up. And also there's this breather tube here, and the way this works is the pressure is so high, pressure's higher here than it is here, and it's a path of least resistance. It's an easier way for the water to go up through this breather tube here than it is to run the whole circuit all the way through the, not the whole circuit, but run the whole path from this trap here all the way up to the top. Instead I can make a direct line to here, and when it gets back to the suction cycle again, you have this check valve here to make sure there's no backflow, so that the water in this tube doesn't flow back into here. So that's how this first stage works. Now the third stage is pretty much the same thing, so that when this thing's going down again, what happens is you have the vacuum and it pulls the water that filled up from the pressure cycle, so the pressure cycle pushes it down into here, this tank fills up, and then on the next suction cycle here, the suction in this tank and this tank sucks the water from here up into here to replenish this tank that was drained out by the pressure. And then also, since this tank is now full, this right here creates a vacuum and sucks the water from this tank here out through this tube and into here. It fills this one up. Then on the next pressure cycle, it just pushes it back down and out into here. So it's just an alternating water staircase, I guess you can say. They called it that back in the 1920s, a water staircase. It just makes its ways up and eventually into here. And depending on the volume as well as the drop of the siphon right here, depending on the volume of the tank here, of the operating tank, and the length of the siphon, which determines how much you can pull on this thing. Depending on that, you can actually extend it up to even more stages. And or alternatively, I mean, you can couple it with more stages, and you can also just stretch the stages out more, so you have more distance between this tank, and so on and so forth. So that's basically how this thing works here. And now I'm going to pause this video and move on to how this thing works in real life. Alright, now we're going to start with how this thing actually works. How this, the principle I explained in the previous video with the patent works with the actual device. As you can see, it's all fully assembled here. First thing that happens is that this thing fills up. This would be like, a higher water marker would be like right here. For the device, to make things easier for myself, since I don't have a river nearby that I can run like a pipe or something into. Instead I have this automatic water feeder with a garden hose, with a piece of tubing coming out with a little garden hose adapter to it, so that this thing, that the water would go up through this tube here, out through this automatic water feeder, and it would fill this thing up. So once it gets to a high enough level, the little feeder turns off and keeps it from overflowing and wasting water. So anyway, this would be the feed tank here, and this would be the operating tank, and this would be the first stage. So what happens is the water from this feed tank goes out through this tube here, runs down, and there's a bit of an adaptation that I made. I'm going to show you exactly how this whole thing works. About right there. Be a good angle. So the water would flow by force of gravity down through this tube here into this drain tank here, which contains a kind of like a substitution for the lever switching device that you saw in that patent. And what happens is it goes through a little float switch here, and goes up to the top and into the bottom of the operating tank. And as you can see, in the operating tank, we have an air tube here at the top. We have a siphon, which you can't exactly see. It also runs out through the bottom here, goes up through the side here and out through this right here, and then goes down into the drain tank again, which is a triggering system. You can look at my, you just go to the drain tank video under where the components and stuff are. Just look for the drain tank video and explain everything there on how this whole switching device works. But it's the very same thing as what Thomas Gaskell Allen was doing with his device, except this is a pulley instead of a lever. And this right here is to make sure that the thing doesn't, sometimes when this thing fills up, there's still some pressure or whatever, and forces the air prematurely out through the siphon before this thing gets filled up. That's what this is to stop. I just keep this on here. It's an optional thing. So anyway, we have the siphon here, and this thing will fill up to the top, and the water will fill up through the siphon here. I'll go over the thing will fill up to the top. The wire will go up through the siphon, out through the top here. Eventually, it'll get to the very top. Go out through here, into the end of the siphon. It'll trip the switch. Switch will turn off. The flow going. Turn off the switch. You'll close the switch in this tank, and there'll be no more water. The water won't be able to flow from the feed tank into the operating tank. This whole circuit will be closed off. So this right here will just keep on draining out through the siphon, and as it keeps draining out through the siphon, want to see where we are. What'll happen is the air right here will get sucked down by the operating tank. The water level will drop, and the air will get sucked down by that kind of virtual piston action. It'll create a vacuum through here, pull the air back, pull down the air through this air tube here, which also runs this T, and the air tube runs through the top to the first stage here, through the top of this thing, through this tube right here in the back, and also the air tube runs up here through the top into the top of this tank right here. So this will be the third stage, this is the first stage, and this is the second stage, and that's the reservoir at the top. So that's what creates the vacuum action. So as the air is sucking down like this, what'll happen is this will be closed off, there'll be a cap on here and everything, and what it'll do is it'll create a vacuum, and the water in this feed tank here will get sucked out through this tube, get sucked upwards through this tube right here, into the bottom of this tank, and go out through the tube that's in the center, in the back of this thing that runs up to the top. So the tube's about this high, and this tank here will flow out through the tube and into the bottom and slowly deposit and collect. So that's how this thing works here. Very same principle. And then when this thing gets to the top, this thing gets to the bottom, what it'll do is the siphon will turn off, counterweight will drop again, and then it'll fill back up again because the switch will be open. The counterweight drops, the switch will go down, this thing will open up, the water will fill back up again, and then it'll create pressure, positive pressure on the air line here. And then the pressure will push down on the water inside this tank here. And what it'll do is it'll push the water up into this tank here through this tube. So it'll push down through this tube here. And there's no fitting on the inside of this tank. There's only a fitting right here on the bottom. So what happens is it pushes it down into this tube, goes up through here, and it goes up through this tall tube here with that check valve on here. There's a check valve. I was say, how there's not a check valve here? I'm confused. Oh, here we go. There's a, I'm getting confused with the tubes too. There's a check valve right here to make sure that the water can only go up into this tank here and out to the back, not back down into here. Same thing with all these tubes. They all have check valves on them. All the tubes from here to here to here to here and to there, they all have check valves in them, except for the air tube because it needs to go back and forth. So anyway, the water runs up through here and it's out through the end of this tube right here, and then deposits in the bottom and slowly fills up. And then what happens is this will be filled up here at the top, and this will fill, this will fill to the top. The siphon will fill up again, go back down, depress the tray, move this counterweight up. You can see the counterweight. I think you can. Not exactly sure. Yeah, you can kind of see the counterweight. And that would pull the counterweight up. The tray would go down. This would close off again, create a vacuum as it drains out through the siphon. And as that vacuum is created, what happens is that both of these tanks are under vacuum, as it was in the beginning, but now there's water in this tank here too. There's water in these tanks, and there's no water in these tanks, or at least there's a little bit of water left in this tank here from the previous cycle, from the pressure cycle. So what happens is the vacuum pulls the water up into here, so that this tank here is pulling on the water in this tank, and this tank here is pulling on the water in this tank. So these two tanks suck the water from the tops here up into here. And then on the next pressure cycle, the water from this tank is pushed up again into the second stage. And this tank right here gets pressurized and pushes the water up through here into this reservoir. And also to show you, the output tube here is the back, goes up through here and up and through here. So then on a suction cycle, that's what this tube does. And the breather tube runs a direct circuit. If you're wondering if I skipped that, no, sorry about that. Breather tube is the one right here that's dangling down. It's touching the bottom here, but it's not closed off. It's the tube here. I don't think you can see it, but it's at an angle. So what happens is that I kind of square at an angle so that there's it can suck the water up into it. It's not laying flat like this, because then you would have a possibility of creating a vacuum. It's like this, so you have some water you can suck up through it, or you can cut the tube a little bit if you want to. Anyway, so that when this thing gets pressurized, the water would push up also through this tube, as well as through the other tube here, so that this would pressurize it directly up through here and up into this tank right here, and then out through this check valve here. So that when there's a suction cycle, this check valve turns off and it can't run back in here and break the vacuum. So that's how the whole device works in practice. And just always make sure that you have barbs and stuff like that. When you're dealing with like soft tubing, always use a barb as opposed to what I used to do with the quick connect couplings. As you can see, this thing right here is in an S. It goes up like this. It doesn't actually have to do that. What it needs, the only reason why it's running like this is that I didn't want to make a really tall shelf and then take this thing and put it up on the top here and have the third stage run up to the top. It could do that, but the problem is that it would just take, the thing would be so humongous. I mean, it would be taller than where the basement is. So I had to run it down through here. And also another reason why this is so long is that I don't want to pinch I don't want the tube to kink. So I have it run this large amount like this. But in theory at least, this tube would just run directly up into the bottom of this thing and out to the top of the tube that's located inside of it or just above it, so that when the water runs out of the tube, it falls into the container. So that's the actual method of how this thing works. Give you a little bit of an idea here too on how this drain tank and stuff works. When this siphon drains down into the fitting that's right here. I don't know if you, hold on, I'm going to put the LCD here to make sure. Yeah, okay, you can see it. Goes through here, so the tube is running through here, across into this fitting here, drains down into here, and there's a tray here at the bottom, and that's what depresses this little float switch here that determines whether it's on or off. And the float switch is upside down, so things are inverted and it can work in this purpose. So the water will flow down and push this switch down here. As the water collects in that tray, it becomes heavier than that counterweight and it can pull it up. And then when the water drains out through this tray here, which has some slits at the bottom of it, what'll happen is the counterweight will take over and pull us back up. So that's how this thing works. And as for if you're wondering, okay, that does that, but how does the water get out of this thing? There's also this little fitting here too. This should actually be a barb. This is a quick connect fitting here. Do not use this. This is just because, you know, I carried over from when I was first experimenting with things. Make sure you use a barb fitting on this thing along with a bulkhead on it. So you have a bulkhead on the wall and you have a barb fitting at the end of this. And that can run out to wherever. I'll explain that in another video about the drain tank. So the water will fall down here, fill up to a certain amount of height, and then it'll just drain out through here without interfering with that switch. So that's how this whole thing really works in practice. And does pretty much the very same thing as what Thomas Gaskell Allen's patent does, how his Hydrautomat works, except instead of having a little lever here with the counterweight and stuff like that, we have a pulley system. And instead of the instead of having this little switch here and stuff, having this little valve at the top, it's located right here is where the switch would be. And this right here would feed in and push a lever down, and the switch would be right here. And the counterweight would be a pulley system. So that's how that all comes together. So now we're going to go on to the next thing, which is not exactly sure now. It might be the fittings or something else, but we'll see next.